Good morning, everyone. Welcome back to another exciting game, mathematics. Whoop, whoop. Warm-up number 46 is on the screen. Let's get started, please. Also, Mr. Marcus has an announcement. All right, if you have those, pass them to the back, and Mr. Marcus will pick them up in the back. Get started, please. Go. All right, here we go. For the sake of time, let's go over that warm-up. Number 1. Here it goes. First dividing point for the green portion is 2. Is that correct? And it's shaded to the left, so that means all these values are x. So question, what are all these numbers compared to the number 2 on the number line? They are what? Less than, and since it's a solid point, notice it's closed, we put an equal sign. Okay. So far so good, yes? Since the two graphs are not intersecting, I told you to use the word what? Or. All right. From there, next dividing point. 1, 2, 3, 4, 5. Okay, there it is, 5. And then we have all these values over here. They keep going, and that is x. So question, what are all these numbers that continue that way? 6, 7, 8, 9, 10, dot, 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 23, and dot, 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 all the way to infinity. What are all those numbers, or what is 5 compared to all those numbers? 5 is what? Less than, and since it's a closed point, we put an equal sign. All right? Let's write that in solution set of x such that, and you close your set. All right? We good? Yes, Mr. Q. Let's go to number 2. Number 2. Here we go. Let me make some space here. My LCD, or least common denominator, I need to use the denominators. This one is x plus 3. Put that in parentheses. I need x, and I need 4x. So I'm going to start with the small ones that look almost the same. Question, for these two to be the same, what does this one need right here? A 4, is that correct? So that means my LCD for these two is 4x. If you bring down the other denominator, since it's a binomial, we just multiply these two. So my new LCD is 4x times x plus 3. All right? Now I'm going to continue giving you some of these in the warm-up because I want you guys to get plenty of practice because December's coming and the next benchmark is coming up. It's a cumulative one. So I'm just giving you a heads up. You multiply the entire equation times 4x, x plus 3. So let's first write our equation again. Leave plenty of room on the numerator for each fraction to write the LCD. So we got x plus 3 plus 1 over x equals 5 over 4x. All right, so here we go. If I distribute this to the first fraction, we got 2 times 4x times x plus 3. Distribute that to the second fraction. That means 1 times 4x. My goodness, that's an ugly 4x, sorry. 4x times x plus 3. And then if we distribute that to the third one, we got 4x times x plus 3. All right. So now that we have that, let's identify the giant ones. Help me with that one, please. Mario. Giant ones. Go. So we bring down 2 times 4x, that is 8x, plus what other? The x. Mario. 1 times 4 and 4 distribute, so that gives us with 4x plus 12 equals, and the last one? That is correct. And distribute the 5. 5x plus 15. That is correct. All right, from there, let's combine like terms. We got 8x plus 4x, that's 12x plus 12 equals to 5x plus 15. Bring the 5x to the other side, so we subtract 5x, subtract 5x. We end up with 7x plus 12 equals to 15. Continue solving. We subtract 12, subtract 12. That leaves us with 7x equals to 3. And last but not least, we divide by 7. X equals 3 over 7. All right, we good? Yes, Mr. Q. All right. Go to number 3. Here we go. Evaluate. And this is going to go a little faster just to, for the sake of time, I want to get to checking the home plate from last night just to make sure we got all the problems done. X, f of x. My domain is -2, -1, 0, 1, and 2. My range over here, I need to substitute these values in here. So f of 3 times -4. So my first value is -2. Here it goes. Mental math. Y'all ready? All right. -2 times 3. -6 minus 4. That's -10. Next one. -1 times 3. -3 minus 4, that's -7. Next one, 0 times 3. 0, that leaves us with -4. So, turn to your neighbor, let them know the last two values, please, of that range. Last two values. All right, last two values. What'd you get, Lisa? -1, -2. Hands if you got that. Close. The last one, though. Help her out with that one. Mario. +2. That is correct. Good save at the end. Kind of almost fumbled that one. All right. So, let's get our domain. Our domain, once again, from -2 to 2. 1, 2, 1, 2. Our range is from -10 all the way to +2. So 1, 2, +2. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you fix this? Oh my goodness. Wow. All right. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. We got -2, -10, -1, -7, 0, -4, 1, -1, and 2, 2, and your line. Something like that. All right. Hands if you got that by yourself. Some of us, yes, good. All right. Give me a second. All right, thank you for sending that in. Copy the agenda, warm-up number 46, intro to functions. Home play for tonight, play sheet Super Q, all only. Last night, I should have put Super Q instead of Q. but that's fine. We'll just switch them off. And just FYI, since the next progress report is coming up, so I'm going to have you go to Canvas right now, and then you're going to go to the class, go to grades, so you can check out. I did an update on the grades, including the pop party from last Friday, so double check on that. Some of you still need to take it, so make sure you come see me in the morning before school or during advisory. Bah. All right? So I'll give you some time. Go to Canvas, look at your grade. You are going to take a screenshot, get that signed by your parents so they can go and take and buy you a Happy Meal or something, right? Ooh-wee. All right? All right, copy the code for home play access for tonight, 5Z4JL. 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 All right, that's for tonight. All right. We good? Yeah? So, once again, tonight, that play sheet. What else? Tell your neighbor what else you need to do tonight for tomorrow. Tell your neighbor, please, so they don't forget. Caesar, what else? Woo, sign your progress report. Let's go. All right? So, with that said, last night's home play looks like this. Get that in front of you, please. And we're going to go over that one together. If some of you did not go over it, make sure you go over it. However, before we do, turn it in on Canvas. So like that, I see what you did. Even if you didn't complete it, I want to see what effort you put into your home play. Freedom. You. All right. So, I'm going to go over numbers 1, 3, and 5. 1, 3, and 5. So if you didn't finish those, copy that one onto your paper so we can go over it together. 1, 3, and 5 from home play. Here it goes. It reads, x is greater than or equal to -5. Write that down if you haven't written that down. Here goes the extra practice. It says, write the inequality. Is it already written? Yes, but in set notation. Set notation. Set notation. So how do you write that in set notation? Well, you write this, and then you just do solution set of x such that, close bracket. That is what? Set notation. Set notation. All right, let's graph this. Here we go. I'm going to use red for this. We start at the dividing point, which is -5. 1, 2, 3, 4, 5. Here it is. However, look at the inequality symbol. Let me zoom in. Does it have an equal sign? Yes, Mr. Q. So that means it's a solid point. Solid point. It's a solid point because it has a what? An equal sign. Okay. Next. Mr. Q, which direction should I go? To the right or to the left? Well, let's test it. Look up. If I want to go to the right, what is the obvious number that I'm going to test? I'm going to test 0. So let's see, instead of x, I'm going to write 0. Is 0 greater than -5? Yes, that is true. 0 is greater than -5. So since 0 did work, I'm going to shade to the right. All right? So, last part. They want us to write the interval notation. Let me zoom out. Interval notation. I'm going to switch to blue again. Interval notation. So, what's my dividing point? -5, comma. Where is this arrow headed towards? It's headed towards positive infinity. So here's to clarify any doubts. For anything on interval notation, we're always going to use parentheses. The only time we use brackets is when the point is closed. Let me repeat that again. The only time we use brackets is when the point is what? Closed. So that means for the -5, it's bracket, and the rest is parentheses. Once again, the only time you use brackets is when the point is closed. Okay, let's go to number 3. So far, so good, yes? All right, here goes number 3. We write x less than -3, but we need it in what? Set notation. So solution set of x such that, and you close it. What is that called? Set notation. All right, let's graph this. Where do I begin? Oh, I begin at -3, Mr. Q. We got 1, 2, 3, -3. Question, is there an equal sign right there? Is there an equal sign? No, so it's an open point. Open point. All right, so let's test to see if I go to the right. Look up. Let's say I wanted to shade this way. I'm going to test the number 0. So is 0 less than -3? Guys, is 0 less than -3? No, it doesn't work. So that means I'm going to shade to the opposite direction. We good so far? Yes? All right. Interval notation. Let's see. Look up. Where does the arrow go to the left? It keeps going. Is there a number on the left? No, it keeps going to what? -infinity. That is correct. Comma. One number is to the right. -3. And I said we always use arrows unless the point is what? Parentheses unless the point is closed. So this is parentheses, parentheses for both. All right, Caitlin, let's go. Go to number 5. Here we go. We start at -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -10. Look at the inequality. Is this does it have an equal sign? No, so it's an open point. Let's go to the other dividing point. The other dividing point is what? 1. Does this have an equal sign? Inequality. Yes, so this is a what? A solid point. Since we have the x in between both of them, that means we're going to shade in between both points. Okay, we good? All right. So we're done with the graph. Oh, we need the set notation. Set notation is -10, less than x, less than or equal to 1. Set notation, solution set of x such that, and you close it. Set notation. So far so good, yes? Yes, Mr. Q. All right, let's go to interval. Let's see. For interval, we start at -10, comma. We end up at +1. Tell your neighbor, what symbols do we use? Parentheses or brackets or one of each or what? Tell your neighbor what we use. And we're going to go with Mario. He's got this. Parentheses or brackets. All right, Mario, for -10, what do we use? Close, because it's an open point. So it's a what? Parentheses. And for 1? Bracket, because it's a closed point. That is correct. 1 month. All right. From 1 to 5, how comfortable are you with that so far? Yeah, we got this, right? Okay, because tonight you're going to do that again. Wow. All right, so we're done with those. Before I move on, send me a picture of those only that you did or that you did right now. I want to see those. If you did them last night, take a picture, send that in, just of those. All right, let's go to the next 5. We got graph each interval, then write as an inequality. So I'm going to do numbers, let's do number 6, 8, and 10. 6, 8, and 10, yeah. All right. So write those on your paper if you haven't done those, so we can do those together. So first thing, we're going to graph this. So let me get some lines here, some number lines. All right, here we go. First one. I'm going to start with the far right. What's my dividing point? My dividing point is 3. So I put 0, and then I go 1, 2, 3. That's on the far right. Question. Since it has a bracket, what kind of point do I use? Close. That is correct. It's a closed point. And then to the left side, look, it's going to the left side over here. It's going all the way to what? Negative infinity. So that means you highlight and draw an arrow. All right, so let's write our inequality. Here we go. Dividing point is 3. All this represented by x. So question, what are all these numbers compared to 3? Less than, and since it's a closed point, it's an equal to. So this is x less than or equal to 3. Oh, yeah. We got this. Let's go to the next one. On the left side, we got +7. So I'm going to put a 0 here. Then 1, 2, 3, 4, 5, 6, 7. And notice that it uses a parenthesis. So what kind of point do we use? Open. Open point. There it is. Open point. How about to the right side? Where are we going? To positive infinity, to the right side. So you highlight an arrow going to positive infinity. Positive infinity. All right, let's write our inequality. We got 7. All this is x. So question, what is 7 compared to all these numbers over here to the right? Tell your neighbor, what is 7 compared to all those numbers? 7 is what? Less than, and since it's an open point, we don't use an equal sign. So my Inequality is 7 less than x or x greater than 7. Either way. Last but not least, do this one. Far left, we got positive 3. 1, 2, 3. Open or close? Joseph, open or close? Oh, what? Open. Yes, open because it's a parenthesis. Then I go to 15, dot, 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 15. Everyone, open or close? Close because it's got a bracket. Highlight in between. There it is. Let's write our inequality. We got 3, 15, x less than, less than. However, this is an open point, stays the same. This is a close point. We put an equal sign, so my inequality is 3 less than x less than or equal to 15. Good? Yes, Mr. Q. All right. Send me your notes for that or send me what you did last night. Either one. I want to see either one. All right. And the last portion of the home play, they give you the graph, and you just write the inequality. So hopefully you got these by yourself, yes? So I'm going to go over, let's see, numbers 1, 2, and 5. 1, 2, and 5. Here we go. They want us to write the inequality, set notation, and interval notation. Here we go. For number 1, -1, +4, x in between, less than. Which one has the equal sign? The close point, right? So that one right there. That's my inequality. Got it. Next, we need to write it in what? Set notation. So you just do solution set of x, such that, and you close it. Interval notation. Interval. I take -1, comma, 4. All right? Close point, bracket, open point, parentheses. Let's go to number 2. Notice for number 2, this is the arrow is going to the right, this one's going to the left, so I'm just going to highlight it. So we got +1 and 23 Michael Jordan. X in between, less than or less than. Both of them are close points, so equal and equal. That is my what? Inequality. Set notation, solution set of x, bar, close notation. Interval, give me the interval notation, but first share with your neighbor, and then Gio's going to give us the interval notation for that one. Share with your neighbor interval notation for that one. All right, Gio, interval notation. Tell me what to write. 1 and 23. And then brackets. Let's go. Tell your neighbor why brackets on that one. Because the point is what? Closed. That is correct. And number 5. Here we go. Arrow is going that way. So I write -5. X, what is -5 compared to all the numbers to the right? What is 5 compared to all the numbers to the right? It's what? Less than, and it's a solid point, so it's equal to. Solution set of x such that, close bracket. Interval notation, I got -5. This is going to what? Positive infinity. Bracket, parentheses. All right, send me that. Or send me what you did last night, one or the other. All right. Thank you, guys. So, tonight's home play sheet Super Q. It's going to look like this. Look up. Which means we need to get to that last example that we did while you guys were rushing out yesterday because of the bells. I'm like, why are they so anxious at the bell to leave? Like, what's going on? Not like if you guys get in trouble or anything, right? You do? Yeah. Anyways, all right, get a Cornell note going, please. You will need at least one graph paper in front of you. Yesterday you got two of them from the back, right? Get that in front of you, please. Our objective for today, I can identify functions. I can identify functions. And reminder, tell your neighbor when tutoring. What time is tutoring here in class? Tell your neighbor, please. What time is tutoring here in class, Enrique? 3:30. And what other time? What? In the morning? Yeah. So before school? Be there or be elsewhere? Anyways. All right, here we go. I can identify functions. We're still in the middle of functions, yes? All right. So we took notes yesterday on order. Oh, you didn't write these, but we talked about order pairs, relation, domain, range. We did one of these, yes? And then we did another one. You did one by yourself, and it looks like this, yes? Then from there we went to our definitions, and we said it's a relation that assigns exactly one output for each input. So before we move on, look up, please. Tell your neighbor why this relation here is a function and why this one is not a function. Remind them, please. Why is this one a function and why is this one not a function? Remind your neighbors, please. Go. All right, Gabriel, why is this relation a function and not this one? And elaborate more. How do we know that? The x and the y, okay, but which one, to be exact, shows us that it has exactly one output for each input? Help them out, Rachel. -2 and 3, so we have -2, the output was 3, and it repeats again, and yes, the output is the same. So why is this one not a function, Renzo? All right, so the last ordered pair, the -2, the first one was a 3, and the second one is not a 3, it's a 7, so that's two different outputs, yes? Pretty good, all right. All right, so we talked about these notations, we did this, we filled that in, and then we talked about Galaga, yeah, is that correct? Let's go, lights please, Monse. And we said the radar like so, and we talked about if I put my ship right here, here goes the recap again. I throw my laser beam, tell you neighbor between what x values that laser beam is going to destroy anything in between. All right? Between what numbers, Joseph? Between 2 and 8. Hands, if you agree with that? That is correct. All right. And here it goes again. Laser beam. Tell your neighbor between what x values? All right. Sebastian, go. -3 and 3. Hands if you agree with that. That is correct. Here goes another one. Now with two different ships. And by the way, have you guys played this game? That if you accumulate, they give you another ship, and then from there another. You can build up to 3 of them, and then from there they give you more. Anyways, pretty cool. How about that one? Tell your neighbor, between what x values? Ashlyn, go. -9 and +4. That is correct. Now, if I wanted you to tell me that as a domain, you would write -9, 4, x in between, less than, and equal because it includes those points. Okay. Let's go now to sideways. We left off here. Look up. All right. Tell your neighbor from the bottom to the top between what two y values is that? Franco, go. 1 and 9. 1 and 9. Hands if you agree with that. All right. From there we go to another one, not without a ship. There it is. Tell your neighbor the last one like this. Between what? Everyone. -3 all the way to 1. That is correct. We go from the bottom to the top. All right. So yesterday we left off on this one. Is that correct? Did you guys copy that one? All right. Copy it onto your new graph paper. We're going to do this one completely together. Just make sure we got it. Let me zoom in so you guys can see the points once again. All right. So, if you have a highlighter, get that in front of you. So imagine this is a spaceship, but it's turning sideways, making a turn. Tell your neighbor, what laser beam do I need to send for my x values in order for me to destroy that? Between what x values? Between what x values do I need to send my laser beam? All right, looks like Mariah's got it. Very good, Mariah. Kelly's got it. I see you, Kelly. Dana's got it. Go with Elijah. Between what x values? From left to right. From what? -5. My laser beam starts here, and it ends where? At 7. Hands if you agree with that. That is correct. So if you want to draw that so that you can see the laser beam, here we go. And then we're going to write the values, -5 and 7 with x in between. So if we write our inequality for the domain, we're going to write less than. Since the 2 points are close, we put an equal sign. This is my inequality. So now that I have my inequality, I want you to write it in set notation. Write that in set notation, please. All right, show your neighbor set notation for that. What did you write? Yeah, -5 less than or equal to x less than or equal to 7, but you write solution set of x such that, and you close it. That's what? Set notation. Lastly, I want you to write me interval notation. Interval notation out of those. Go. All right, looks like Jesus got it. Jesus, go. Bracket, -5, comma, and bracket. Hands if you got that. That is correct. All right. But that's what? The domain. Label that domain. This is only x values. Notice they are all x's. So now I want you to take your highlighter, look up, and now we're going to look at it through this side. What beam do I need to send in order to see what y values cover that? All right? What y values, between what y values from the bottom to the top do I need to send my beam through? All right, tell your neighbor, between what y values? Rogelio, between what y values? -2, okay. Draw your highlighter through -2 of y. And it goes all the way up to what? +4. Hands if you agree with that? That is correct. So from -2 all the way to 4. So let's write it over here. -2 all the way to 4. But in this case, since it's sideways, we don't write x. What do we write? Y. Less than. 2 points are closed. So we write equal to. That's my inequality. All right? Write the set notation for that and the interval notation. All right, give me the set notation, please. Annette, go. Bracket, x, bar, -2, and close bracket. Hands, have you got that? All right, interval notation. Show your neighbor your interval notation. Yes. Oh, this one's for the y. Sorry. Yeah, we did that on purpose to see if you guys were paying attention. Very good. Yeah, Rachel said, Mr. Q, so for this one, do we leave x? No, this is y. Very good. All right. So you neighbor the interval notation, and then Annette going to pass to someone. Interval notation for that. Pass someone, Annette? Abby? -2 and what do we use? Brackets. Hands, if you got that? From 1 to 5, how comfortable are you with that? You got it, right? All right, so with that said, let me send you a screen so you can send me your graph and your notes for this one. Send me a picture of that. All right, let's go to another graph paper, and I want you to sketch this. I'm going to give you a point, let's see, starting at -2, 2. Catch that, please. This is a new alien ship coming to us, and this one's going to go like this. It's one of those weird ships that they send. Let me fix that last point. Hold on. There it is. All right. All right. So, talk it over to your neighbor. Look at the x values. From where to where do we need to send that laser beam? From where to where? Then Caitlin's going to enlighten us with that one. So, you know, from where to where do we need to send our laser beam? All right, Caitlin. From -2 all the way to 6. Hands, do you agree with that? That is correct. So let's write those numbers down here. -2 all the way to 6. X in between. Less than and less than. However, which one's the open point? Which one's open? The 6. Is that correct? So that one, we don't put an equal sign. We only put an equal sign on what? On -2. And you know how to write the set notation and interval notation, yes? Write those down, please. And the range. Here we go. From the bottom to the top. Where do I start? Geo. So that we can leave on time. From the bottom to the top. What is the lowest y value and the upper y value? Zero. Looks about right. There it is. And the upper value? +5. It looks about right. So let's see. 0 and 5. Y in between. Less than and less than. Which is the close point? The close point is all these down here. So that is, hold on. And the open point is that one. And you know how to write set notation and interval notation. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.